Hans for this invitation to present this case, and thank you for the audience to hear this presentation. I hope it will be useful for you all guys. So to go directly to the presentation, we will talk about a success case of 500 standardized energy audits in small and medium-sized dairy farms. Uh, the main objective of this project is to reduce energy consumption in dairy farms, but I think this approach is also suitable for all SMEs. That means for small and medium enterprises. That it's a big consumer of energy when we take them all together, but everyone consumes a very small amount of energy, so always they are in the end of the list of priorities for energy auditors or for ESCO's companies. So I think this approach is suitable for replicating it in other sectors of SMEs. So to proceed to the presentation, first of all, to present the project. This project is funded by the FOMIN. It's a multilateral investment fund, a member of the Inter-American Development Bank, and CONAPROLE, which is a big company in Uruguay. I will talk about it later. And its purpose is to improve the energy efficiency of dairy farms in the framework of a strategic alliance with UTE, the state-owned electricity company, the utility company in Uruguay. And the main goal of the project is to improve the energy efficiency of 500 dairy farms. A standardized methodology for conducting 500 low-cost energy audits in small dairies has been developed, and the project already audited 350 farms. This means 70% of the goal, and the project is expected to finish by April 2016. So to talk a little bit about CONAPROLE, is the National Milk Producers Cooperative, founded in 1936. It's by far the largest producer of dairy products in Uruguay. The dairy sector in Uruguay amounts 4,291 dairy farms. In 2013, we had a record of exports in Uruguay of dairy products with $924 million. In last year, the dairy exports represented approximately 8.3% of total sales of goods from Uruguay. That means that the dairy sector represents the number 4 in the ranking of exports from Uruguay after soy, meat, and cereals. So let me tell you also that the average annual growth in milk remission was 6% in the last 5 years. Every year we are growing, so it's a sector that it's already big for the Uruguayan economy, and it's also growing quite fast every year. And CONAPROLE, this company, that it's a cooperative, represented 64% of total sector exports in 2014. So if you are a Uruguayan, you for sure know the CONAPROLE products, milk, cheeses, butter, all the dairy products from CONAPROLE are very popular here in Uruguay. So a little bit about the organization of the project. We have at the top of the organization chart a manager from CONAPROLE, then a project coordinator from the FOMIN, the IDB, also an assistant to the project coordinator, and then you will see the abbreviation in red, DTA. That means the audit technical director. That's me, Ernesto Elenter. I am the technical director of the program, and then I work with an energy efficiency analyst, AET for its abbreviation, and then 3 auditors. The AET, every one of those guys are the ones who visit every farm in the country and are the ones who visit the producers and talk with them and gather the data and everything that I will explain shortly. So this is the audit process. First of all, the dairy farmer registers himself through different ways. Then the assistant of the project calls him by telephone and collects some preliminary data. Then the assistant assigns an auditor. Then the auditor collects the data, visits each farm, and makes the audit, the energy audit. Of course, these people had previously some courses on how to do that. And they make some measurements in the dairy farm, and they collect all the information, talk to the owner of the farm and everything, and then all the information is sent by email through an Excel datasheet. Then the energy energy efficiency analyst prepares the savings report. That means the energy efficiency audit report. Then the technical director reviews, makes corrections, and approves the report. And finally, the auditor again takes the report and goes back to the field, visit the farmer, and give the feedback of all the study, letting him know what were the findings of the energy audit with the savings measures suggested. And then he talks with the farmer and gets a commitment from the farmer about what he think he will implement of those suggestions. The idea is to get a commitment in the place in order to let us follow and track the implementation after we give to the final client, that means the dairy farmer, the report. So after that, this process takes about 1 month. After that, we keep tracking and recording and documenting the implementations of every dairy farm. This is very interesting, this pie graph. You can see that the total audit cost is only $600 per audit, where the dairy farmer only pays $170. It's very cheap for him. Where the FOMIN, this part of IDB Bank of Development, Bank, subsidize part of the total project cost with the difference, $430 per audit in average. And for me, that I work a lot since 1990s, or 2000, an energy audit for an industrial process, it's always has a cost of some $1,000, not less than $1,000. So it's a very cheap audit for a farmer, and we could achieve this low cost only because of the standardization of the process of the audits. So let me explain to you a little bit about how a dairy farm works. They are all almost very similar one to each other. To the right you see the milking room with those blue pipes are the vacuum pipes where the milk is conducted to the machines and the cooling vat. So the cows are milked twice a day. It takes 2 to 3 hours typically, the duration of the milking process. Each cow is around 7 to 10 minutes in this place, and then a new one gets in the milking room. Every day the milking lines are washed with hot water to preserve the quality of the milk. And the milk is collected every day or every 2 days by trucks that comes to every farm and takes the milk to the industrial complex of Conaprole. So to the left you see the cow at the upper part of the diagram. The milk comes from the cow at around 37 degrees Celsius. Then a vacuum pump makes the depression of about 45 kilopascals, and a milk pump conducts the milk to the milk vat, where it's refrigerated to 4 degrees Celsius approximately with a chiller unit. And sometimes we have a plate cooler. This is a heat exchanger to reduce the thermal load of the milk with the fresh water. And in the upper right part of the diagram, you see some water heaters. Those are the devices to heat the water to wash the lines. So at the beginning of the project, we tried to quantify the specific energy intensity of these farms to design an NP, an energy performance indicator, as is established by the standard ISO 50001. And we did so with this indicator that is how many kilowatt hours per 1,000 liters of milk produced. And we did it in 3 scales. The first one is for small farms, less than 1,000 liters a day of production. The median of this indicator for this range of dairy farm size is 81 kilowatt hours per 1,000 liters. The same for medium size dairy farm, between 1,000 and 3,000 liters per day. The median of this indicator is 51 kilowatt hours per kiloliter of milk production. And for big ones, for large dairy farms, more than 3,000 liters a day of production, the median of this indicator is 42 kilowatt hours consumed per 1,000 liters of milk produced. So with this indicator, we designed an energy efficiency labeling for dairy farms to emulate or to copy the idea of domestic appliances, labeling that let the farmers to understand easily how well or bad are they consuming energy compared with the rest of the industries, like a benchmarking. We have to take into account that the farmers are people that are quite isolated in the middle of the countryside, sometimes with no access to consultants or specialists in energy efficiency. So this labeling system showed it to be very useful to the farmers to understand where they were in terms of energy efficiency. So we see there that in this case, the energy intensity in this case is 40.2 kilowatt hours per kiloliter. And this means a C category in the middle of the table. And we show this energy efficiency label for in every report we make for the farmers. Here you can see the map of Uruguay to the right. You can see at the south the Atlantic Ocean. Montevideo at the south is the capital city of the country. It's where I am sitting right now in my office. To the east, Brazil. To the west, Argentina. And you can see every dot is a farm, an audited farm in the country. You can see that are quite disseminated in the whole geography of Uruguay, and every color represents the category of the label we found. As was expected, almost 50% of 49% of the cases are in the category C. So this was a good reference for the farmers to understand where they were in terms of energy efficiency. So going ahead, let me explain briefly the characterization of energy consumption in a dairy farm. In the case of Uruguay, the first energy user is the milk storage vat. This is the cooling tank where the milk is stored and refrigerated. So these tanks reduce the milk temperature from 37 to 4 degrees Celsius in less than 2 hours. And this explains, as you see in the pie chart on the right part of the slide, 34% of the energy is consumed in average by this cooling system. The second energy use in a dairy farm is the milking machine, and its function is extracting cow's milk, and the main elements, of course, is the vacuum pump that makes the depression of about 45 kilopascals to make the vacuum necessary to extract the milk from the cows, and this explains 26% of the energy consumption in average. The water heating process for heat water for washing purposes. Typically, they use electric water heaters, but there are also some cases that use wood, LPG, or solar collectors, but mainly electric water heaters. And this explains, in average, 16% of the energy used in farms, in dairy farms. Other hydraulic system pumps for pumping water, milk, or effluents. This explains 14% of the energy consumption. And as a summary of the mix of energy use, you can see at the left the typical energy distribution in Uruguay, and at the right in New Zealand. We took this from a different report that we use it as a reference. You can see that water heating, for example, is only 16% in Uruguay, where in New Zealand it amounts to 29%. And this is mainly because of weather differences. We have mild weather in Uruguay. Our average temperature around the whole year is 17 degrees. New Zealand, it's cooler, the climate, so they consume more in heating and less in cooling of the milk. So let me explain to you roughly the energy conservation measures. We call them ECMs, energy conservation measures, suggested as a result of the audits. The first one is the heat exchanger, the plate heat exchanger, that transfers heat from the milk to water, carrying the pre-cooled milk to the milk pad. As you see in the down part of the diagram, the cow with the milk at around 35, 37 degrees Celsius, the milk goes through a plate heat exchanger, and in the other direction, fresh water crosses this heat exchanger and leaves it warmer, and the milk loses from 35 to 24 degrees. This is just an example. It depends upon the flows and temperature of the fresh water. And we suggested this idea to 65% of the audited farms. Regarding the variable speed drive to regulate the operating speed of the vacuum pump, as you can see in the diagram, in the graph below, without the variable speed drive, the consumption of power or energy is constant the whole time that the pump is working. And when we use a variable speed drive, it regulates the speed. That means the energy consumed with a sensor of depression, and has we measured these savings in some cases, finding 64% of energy savings. It's a lot, but it's real. And we suggested this idea to 42% of the farms, not to all of them, because for small farms it's very expensive, this variable speed drive, considering the savings involved. So only for 42% of the cases we suggested this idea. And if you see at the lower part of the slide, you can see that we found that the noise reduction from 72 decibels to 62 decibels was an unexpected important non-energy benefit. The farmers that installed this technology told us that they were very happy because the quality of life of the people working at the milking room were really happy to have this noise reduction. That it's, of course, it's not an energy saving measure, but it's a non-energy benefit that was highly appreciated. Then the use of solar energy to preheat water for washing purposes. We suggested this idea in 55% of the cases. Then a very interesting technology called heat recovery tanks. The function is to preheat water for washing purposes also. And if you see at the down at the right of the milk storage vat, you can see that the cooling unit uses a liquid or gas refrigerant that is compressed. It reaches a high temperature, and instead of rejecting all the heat through the air-cooled condenser, the hot refrigerant goes through a heat recovery tank with a heat exchanger, where it leaves some part of the heat and preheats the water and comes back to the condenser at a lower temperature. So you have two benefits from this process. You preheat the water, sometimes to 70 degrees Celsius, that it's enough for washing purposes, and at the same time you can save some electrical energy at the cooling system. This was suggested in 32% of the cases, also because it's a quite expensive technology, so it's more indicated for big farms, for large farms. This one is a very simple one, a timer to limit the operation of the electric water heater to avoid using it in times where the dairy farm is not operating at all, and to avoid peak hours when the rate is more expensive. We suggested this idea to 72% of the cases. And this is a summary of rates and power factor optimization suggested as a result of the audits. We can also save money without saving energy. That's very important for the economy of these energy efficiency studies. For example, the first one, electricity rates, to switch from simple rates to smart rates, where the energy has different prices depending on the time of usage of the energy, provides important savings in many cases. We suggested this to 30% of the cases. To adjust the contracted demand, reducing or increasing the contracted demand in terms of the power hired to the electric company. And lastly, but very, very popular measure, the power factor correction by installation of capacitors bank to reduce reactive energy was suggested in 82% of the cases. It's very interesting to know that a lot of farms were paying penalties or fines to the electric company because they didn't know about this very, very simple way to reduce energy cost by installing capacitors to reduce reactive energy consumption. We also take advantage of all this process to make some suggestions regarding electrical safety in the installations and capacity requirements of the dairy farms. For example, general security or safety conditions, sealed boards, the grounding, regarding capacity suggestion to increase the milk vat tank capacity, increase the number of milking cups, increasing hot water capacity, some suggestions regarding the capacity, not only, or safety, not only energy savings. That was an independent output of this project. So measures on milking schedule suggested as a result of the audits. Also, we suggested in a lot of cases to change the milking time schedule to avoid peak hours. As you can see, in Uruguay, the most expensive energy is between 6 p.m. to 10 p.m. This is the red area of the pie chart. And then we just adjusted to shift or to move a little bit the schedule to take advantage of the reduced energy cost of the energy that made important savings, and we suggested this idea to 65% of the cases. So here we can find a summary of the outputs or the savings expected for each measure. For the heat exchanger, that was suggested in 65% of the cases, 75% in small dairies farms, 72% in medium farms, and 52% in large farms. And you can see at the table that in terms of dollars per month savings, that meant $28 per month for small farms, $55 and $142 for large farms, and the average is $75 per month, what means 12% of the cost. In terms of energy, this average amounts to 400 kilowatt hours per month, what means also 12% of the energy cost. This is an important saving. This picture is repeated for each measure. I will go quickly through these slides. The variable speed drive, if you see the average savings is around $69 per month and means 8% of energy cost savings. The solar panels are taking advantage of solar energy. It saves $19 per month, what means 4% savings. The heat recovery tank can give savings in average of $72, what means 9% of savings. The timer, it's a very cost-effective measure because it's very cheap to install it, and the average savings is around $13 and explains 2% of savings. And as a summary of the energy conservation measures reported for small dairies farms, first of all, let me tell you that the monthly average consumption it's only 1,537 kilowatt hours per month. That means only $323 per month. This is the cost of electricity for these typical small dairy farms. And the rate in average is 21 cents per kilowatt hour. We made in those cases an average of 11 suggestions, and the monthly savings are 246 kilowatt hour per month, what means 16% of the energy, but means $134, what means 41% of the cost. This is because all those measures that I told you that they do not represent energy savings but cost savings, like reactive energy reduction or switching the time of the milking in order to take advantage of better rates and to use energy when the price is cheaper. In those cases, the investment, if all the suggested measures were implemented, is $2,800, what means 2.2 years of payback period time. The same for medium dairy farms. I will just tell you the important numbers. 490 kilowatt hours per month of savings, meaning 20% of energy savings, and almost $200 per month, meaning 40,000% of savings. And for large dairy farms, 19% of savings and 35% of energy cost savings, amounting to $406 per month, with an average investment of almost $7,000 and 1.8 years of payback period. So far, the partial result of implementations, because all the ideas I have been talking to you are the reported savings, but not all of them are implemented, of course. So far, 56% of dairy farms audited have implemented and documented at least one of the suggested measures. That means that more than half of them have already implemented at least one suggested measure. And it is estimated that exists an important number of undocumented implementations. Another 50% we estimate that it's also already implemented but not yet documented. With documented, I mean that because this project is funded by the IDB through the FOMIN, we need to document every implementation with a copy of the invoice of the investment made or performed by the farm. So it's quite difficult to document these implementations and to get these invoices from the farmers. So it's a challenge for us to document with this quite bureaucracy these installations. So we think that we have a lot of more implementations than what we can document. The investment from the dairy farmers till now more than $700,000. And as a conclusion of all this presentation, we can say that we conclude that it is possible to improve the energy performance of dairy farms by incorporating various cost-effective measures. Polls showed high level of farmer satisfaction. We made some polls with asking them the level of satisfaction, and we found a high level of satisfaction. The average savings per farm funded program is 721 kilowatt hours per month, meaning 20% of consumed energy in average, meaning $263 per month, meaning 38% of electricity bills. In average also with a payback period between 1.8 and 2.3 years for returning the investment paid with the savings obtained. The other conclusion is that this approach is suitable for all kinds of small and medium enterprises, and this experience could be useful to design and develop energy efficiency programs in SMEs. The next challenges for the project is to finish the goal, that means to reach 500 audits by April 2016. The second is to increase the level of implementations to try to let all the farms to benefit from the savings that are really cost effective. And the last one is to measure verification of the real achieved savings that it's in our pipeline of studies to perform in the near future. And just to leave to you some references, you can find in this slide some information of the project, of the funding, of the dairy sector in Uruguay, and some references of other technical energy efficiency reports from New Zealand. So that's all from my side. Thank you very much for your attention, and of course, if there are some questions, I would be very happy to try to answer them. Thank you so much.